Who remembers some of the key concepts you learned regarding atomic structure? For this lecture, you should know the meaning of the words atom, element, atomic number electron, electron cloud. Remember that every atom has a certain number of electrons, which orbit the nucleus in the electron cloud. These electrons orbit in different energy levels, which are known as electron shells. The first shell can house 2 electrons, and it must be full before any electrons can move to the next shells, which can house 8 electrons each. 1. Which element is depicted in the diagram to the right? 2. How many electron shells are pictured in the diagram? 3. How many electrons are in the outermost energy shell? Lewis dot diagram. In chemical reactions, the electrons in the outermost shell are the most important. We can represent elements using Lewis dot diagrams, which visually emphasize those electrons over the others. The electrons in the outermost shell of an atom are known as valence electrons. In the Lewis dot diagram to the left, you can see that beryllium has 2 valence electrons. How many valence electrons do you think hydrogen has? How many does oxygen have? Partially filled electron shells are unstable, so all atoms want to fill their electron shells completely. Since most shells can hold 8 electrons, this phenomenon is known as the octet rule. Atoms fulfill the octet rule by forming bonds with other atoms. Check your understanding. As an example, fluorine has 9 electrons and 7 in its outermost shell. It will need 1 more electron to fill its octet. How many electrons would carbon need to fill its octet? How many would sulfur need? And xenon? Hint: take a look at the periodic table if needed. Chemical bonding. When atoms form bonds with other atoms, it is known as chemical bonding. Atoms will form chemical bonds with each other in order to fill their electron shells and gain stability. Some elements have atoms with the ideal number of electrons needed by others. This makes certain pairs of elements more compatible for bonding. There are 2 main types of chemical bonds, ionic and covalent. Ionic bonding. Some atoms need to lose electrons, whereas others need to gain electrons in order to be stable. If the atoms are compatible, they will engage in an ionic bond to accomplish these goals. Ionic bonds take place when one atom steals the electrons of another atom, resulting in stability for both atoms. Sodium has 1 valence electron and chlorine has 7. Sodium can become stable by losing its single valence electron and dropping down to the previous, and complete, energy shell, whereas chlorine can become stable by gaining 1 more electron and filling its outermost shell. These atoms can form an ionic bond in which chlorine steals sodium's single valence electron, creating stability for both atoms. Some atoms may have a number of electrons such that gaining or losing enough to fulfill their octets is challenging. These atoms may engage in covalent bonds instead of ionic bonds. Covalent bonds take place when, rather than taking or giving electrons, atoms share their electrons in order to fill their energy shells. Chlorine has 7 valence electrons and therefore needs 1 more in order to fill its octet. In the absence of any other element, chlorine atoms can bond with other chlorine atoms. Both atoms will share 1 electron, thereby completing their electron shells.